Okay, this is the second half of our fourth part of our lecture for Wednesday, March 22nd. We are practicing how to predict precipitation products by following this kind of general process here. We just looked at the reaction of calcium chloride with silver nitrate and determined that we did form a precipitate or a solid insoluble product. That was our silver chloride. And now let's look at another example, which is sodium sulfide and barium acetate. Again, if you were having trouble naming these compounds, you need to review the nomenclature conventions that was given in our naming workshop, as well as our list of polyatomic ions, which you do need to have memorized. So let's go back up to our general process, which starts by saying 1, write out the reactants involved. Specifically, let's try to figure out what kind of ions each of these aqueous reactants will contribute to solution. Okay, so sodium, it is a group 1A element, group 1A metal. This forms a +1 charge, and the subscript tells us that when sodium sulfate dissolves, it will contribute 2 sodium plus ions to solution. Sulfur, the sulfide anion, that is in our group 6. So this has a -2 charge. Again, if you need to review this, just check on your periodic table. So we've got -1, -2. Ooh, not negative. Oh my goodness. Metals do not form negative charges. +1, +2, +3, +/-4, -3, -2, -1, and then no charge. All right, so sulfur, when becomes a sulfide anion, has a -2 charge. So that's how I knew that this would be the sulfide anion. Okay, barium, Ba. This is in our second column, so this has a +2 charge. And it is with the acetate polyatomic ion, which we know from memorization has a -1 charge. So we create 2 acetate ions in solution when we dissolve barium acetate. And now we need to look what's next, which is swap your anions or do the double displacement. Okay, so I'm going to have the sulfide anion now become associated with the barium cation. And then I'm going to have the acetate anion be now associated with the sodium cation. So let's figure out how we can put these ions together and do step 3, which is to make our product compounds such that they are charge neutral. So we're trying to figure out like our subscript balancing first before we move on to balancing everything else next. So let's start with our barium and sulfide. So barium has a +2 charge, sulfide ion has a -2 charge, so this ratio is going to be 1:1. So I create BAS. And then I've got now sodium, which has a +1 charge, and acetate, which also has a +1 charge. So these are also going to couple in a 1:1 ratio. Okay, so I've made my charge neutral products. So that was step 3. Put your product compounds together such that they are charge neutral. And then step 4 is to reference our solubility rules to determine if a precipitate is formed. So we now have our product compounds. Let's see if we can't find rules associated with their solubility. So I see right off the bat that we have an acetate, and I do have a rule for acetate, which says that all acetates are soluble, except for silver acetate, which is only kind of soluble. And I also recognize that I have one of my universally soluble cations. So sodium acetate is definitely soluble, meaning it will stay dissociated into its respective ions when it's in solution. And let's now look at our next product, our barium sulfide. So I don't see a rule for barium enumerated or listed here, but I do see a sulfide rule. So the sulfide rule, all sulfides are insoluble except those of sodium, potassium, and then we have hydroxides of barium and calcium are slightly soluble. So slightly soluble is a way of saying kind of like sparingly soluble. So you might not see like a massive quantity of solid buildup in your reaction vessel, but we will still see a little bit of solid being formed, meaning that we have this kind of partially soluble precipitate. And this came from our sulfide rule. Okay, lastly, step 5 is to balance our overall equation. So we need to balance our chemical equation. On my reactant side, I have 2 sodium atoms, and yet on my product side, I only have the 1. So I need to double the quantity of sodium atoms on my product side by doubling my sodium acetate. In doing so, I have doubled not only our sodium, but also the acetate. So I have now 2 acetate ions on the product side, but I already started with 2 acetate ions looking at the subscript here on my reactant side. So it looks like we're balanced in acetate. Let's check now on our sulfide ions. So sulfide, we have 1, and then 1 on the product side. So we are balanced there. Barium 1 and 1. So now we are overall balanced, and this is the precipitation reaction forming the sparingly soluble or slightly soluble barium sulfide precipitate. So as long as you are referencing your solubility rules and paying attention to the exceptions and looking for charge balanced products, you should be able to identify whether or not a precipitate is formed. And before I let you go for the day, let's look at our in solution view. So let's situate ourselves inside our beakers. So here is our pre-reaction. And then we've got our post-reaction. Conditions. Okay, in solution, before the reaction happens, I have my 2 aqueous reactants, meaning we have fully dissolved and dissociated ions. Specifically, I have, looking at my work I did here, 2 sodium plus cations, and then the sulfide anion. And then I have my barium 2 plus ion, and then 2 acetate ions. And we know that the ion association that's going to happen is the one between barium and sulfide, and then each of our sodium and acetate, right? That's the double displacement. And I would see probably sparingly, so it would look pretty faint to you, like not a major clump. Maybe something that hasn't stuck to the full bottom yet, so I'm gonna write this as suspended. You might have, I don't know, 1 particle of barium sulfide. And then we would have, again, our aqueous sodium acetate. So this would be shown as fully dissociated, so 2 Na pluses and 2 acetates. This is what we would see in our beaker or a reaction vessel once the reaction has occurred. Probably might see some very light cloudiness. And then we have these sodium acetate ions still fully dissociated because sodium acetate is a soluble product. Okay, so that is it for lecture today, Wednesday, March 22nd. When we see each other, when we review our lecture on Friday, we're going to talk about how we can use this perspective of what ions are in solution and their resulting products to build different types of chemical equations that might be more useful for us depending on what kind of context we're talking about. And then we're going to move on to our next type of double displacement reaction, which are neutralization reactions or acid-base reactions. So I will see you all tomorrow, hopefully, if the power's back on campus. If I don't, then have a wonderful spring break, and I will upload lecture on Friday.